let's talk about switches, specifically a MOSFET switch, if I can say that correctly. So we're all familiar with this type of switch, right? On, off, on, off. Basically a manual mechanical switch. But what if you wanted to use one of these called a MOSFET? Okay, now MOSFETs typically have 3 pins. The gate, the center is a drain, and the last pin is the source. So let's take this and put it in a circuit. Voila! Here we are. So we've taken a MOSFET, we put it there. I've actually taken this off a circuit board, so it looks a little rough, but anyway, it's in the board. And what we've done is we have an 18650 battery. We have the negative going down to the negative rail here. We have the positive of the battery going to the top of the rail. And this is just a resistor, so we don't blow the LED out because the battery is a little bit too much voltage for it. And what we're going to do is we're going to take the negative of the battery and take it to the source pin of the MOSFET. And then we're going to take the positive of the battery and put it to the positive leg of the LED, which then is connected up to the LED to the negative side, which goes to the drain. So what happens to turn the LED on? All I need to do is stick this wire in here and touch this to the positive side of the battery. And voila, the LED turns on. If we want to turn it off, we can touch it to the negative side of the battery. And in this case, all we have to do is touch it to the source there, and it will switch off. So we can go on, off, on, or obviously down to the negative part of the battery, we turn it off. So when using one of these in a welder, you can turn it on. We can disconnect the power. MOSFET, the light goes off, but the MOSFET's been left in a state of on. So when I connect it with power again, you see that the MOSFET is still in the on position. So it's important when you design a circuit is to turn that off. And I'll show you that next. All right, so now we're back at sort of everything I've put together. We just took that same MOSFET we had in the previous video, and it's all wired in. There's a battery to turn that light on, LED on. This is the capacitor timing circuit, so it automatically will adjust the pulse time depending on the capacitor you have. And I'll demonstrate that. I know you've seen it, but to see it all working together is kind of nice. My foot switch over here, this was all parts scavenged from a used microwave. But anyway, so we'll close the foot switch up, turn that around that way. Oh, actually, it was used in this position. And what I'm going to show you now is just turning on the LED light. So this relay here gets the trigger from the foot switch. It goes through here, grabs the voltage that's in here, and sends that down to another relay, which turns on the solenoid. So this is a solenoid. I plan on trying some solenoid welding as I build out the MOSFET switch. So I'm just using one MOSFET right now as an example of how it works. So theoretically, if you put a bunch of MOSFETs together, then you can use it on a battery to handle that amount of amps going through it. So let me just show you how this works right now. So you press the switch on, and you notice that the light comes on. It stays on because we left the MOSFET on an on state. Now this whole circuit up here automatically recharges the capacitor, so you don't have to have a separate trigger. All right, so here's the magic ingredient to turn that MOSFET off. There's another relay here for some reason, I need the resistor in here to get it to come on. And I'm not sure why. But anyway, there. So we'll turn that off. Okay, so if I... Voila. So this whole circuit on here is automatically recharging the capacitor. And when it fires, the LED comes on. And then after it stops firing, this relay kicks in from this relay and causes this to go to the, I think it's the gate, which then discharges the MOSFET. So again, this is kind of the action we have here. And if for some reason I thought that pulse was too short just for illustrative purposes, let's put this, that one was 470 microfarads, I believe that's called. And this one's 3300, just to show you the difference in timing from one extreme to the other. This is a 12 volt. This is just an indicator showing that I have power from the power supply. So let's fire that off. And you can see that that stays on for a considerably length of time. But just to give you an idea of how that works. So that's kind of my Frankenstein right now. I need to condense it up, but this is a working model. And I'll, once I get this built, the welder, I'll try that. But I've gone through a number of MOSFETs by blowing them up because I had reverse polarity or shorted things out. They are very sensitive, and that was just working with 12 volts on these. So I finally got to a place where everything's working. And yeah, so I just thought I'd share that with everyone. Maybe there's some learnings in there. And I'll put some links to the videos that I got this information. Thank you.